Let us build a math tutor that does not just explain a method. It writes and runs Python to actually solve the problem, shows the steps, and remembers the conversation. We will use the Azure OpenAI Assistance API, and the code is Microsoft's own API in a box sample. In this deep dive, we cover what the Assistance API is and how it differs from a plain chat call, the prerequisites, every line of code, and the pitfalls, so you can build a stateful, tool-using assistant of your own. First, why the Assistance API at all? With a normal chat completion, you are stateless. You must resend the entire conversation history yourself on every call, and the model cannot run code. It can only produce text. The Assistance API changes both. It gives you a persistent assistant with instructions and tools, and a thread that stores the conversation for you. So state is managed server-side. And it supports built-in tools like Code Interpreter. So the assistant can execute Python to get exact answers. You trade a little more structure for memory and real tool use. 3 objects to keep straight, because the code maps to them directly. An assistant is the configured worker, its model, its instructions, its tools. You create it once. A thread is a single conversation. It holds messages and persists. You make one per user or session. And a run is one execution of an assistant against a thread. It is where the model reads the thread, decides to use a tool, runs it, and writes a reply. Assistant, thread, run. Every line we write creates or drives one of these. Prerequisites here are an Azure OpenAI resource, not the Foundry agent service we used earlier. And inside it a model deployment, for example GPT-4o, with a deployment name you choose. You will need 3 values: your Azure OpenAI key, your endpoint, the resources URL, and that deployment name. You also pick an API version string, which selects the API surface that supports assistance. A quick sanity check. If you can call your deployment from the Azure OpenAI playground, you have what you need. Setup is light, just the OpenAI Python package, and Pillow if you want to render any images the assistant returns. Export your Azure OpenAI key and endpoint as environment variables, and remember the deployment name of your model. Keep keys out of source, read them from the environment. With those 4 values, key, endpoint, API version, and deployment name, we have everything to connect. We import Azure OpenAI from the OpenAI package and create the client with 3 things: the key, the API version, and the endpoint. This is the standard Azure OpenAI client, the same one you would use for chat or embeddings. The assistance features hang off it under a beta namespace. If this constructs and a simple call works, your credentials and endpoint are correct, which is the first thing to check if you hit an authentication error later. Now we create the assistant. We give it a name, instructions that define its job, be a personal math tutor and write and run code to answer, and the tools list with a single entry, type Code Interpreter, which is what lets it execute Python. Critically, the model parameter is your deployment name, not a public model name. This is the most common mistake on Azure. Then we open a thread, an empty conversation that will hold the student's messages and the tutor's replies. To ask something, we add a user message to the thread with the question: solve 3x plus 11 equals 14, show your steps. Then we create a run, which ties this thread to our assistant and kicks off the work. At this moment, the assistant reads the thread, recognizes a math problem, decides to use the code interpreter, and writes Python to solve it. The message and the run are 2 separate steps. The message records what the user said. The run is what makes the assistant act on it. Runs are asynchronous, so we poll until the status is terminal. The poll helper blocks until the run is completed, failed, or cancelled. When it is completed, we list the thread's messages, which now include the assistant's reply, and print them. You get the worked solution, the steps and the final answer, computed by Python. The assistant wrote and ran, not guessed token by token. Always check the status. A failed run will not raise. You have to inspect it, which is the second most common mistake. The payoff of all this structure. The thread is stateful. Ask a follow-up like, now solve for y in a related equation, and you do not resend anything. You just add a message to the same thread and start another run. The assistant already has the full context. That server-side memory, plus the code interpreter for exact computation, is what makes this feel like a real tutor rather than a one-shot answer. And because it is the same shape as the OpenAI Assistant's API, skills here transfer directly. The practical notes that save you hours. 1. On Azure, the model parameter must be your deployment name, not a public model name. This is the #1 error. 2. Match a supported API version. An old one will not expose assistance. 3. Always check run status. Failed runs do not throw. 4. Assistants and threads persist on the service and cost storage. Delete the assistant when you are done experimenting and reuse it in production. And note, the assistant's API is converging with the Azure AI Foundry agent service. So for new builds, check which one Microsoft recommends today. That is a complete, stateful tool using Math Tutor. It is the Math Tutor sample from the Azure AI samples repo under Scenarios, Assistants, API in a box, linked below with the path. The same folder has a personal finance assistant, a failed banks analyst, and more. Swap the instructions and the tools and you have changed its entire job. Subscribe for the rest of the series and go build your own assistant. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.